Hello, friends, and welcome to this other session of the Kubernetes Fundamentals series, only in CSharpCorner. I'm Rodrigo, and today I'm going to talk about resource boundaries, which is necessary when you're trying to implement Kubernetes because your containers are gonna require a lot of CPU and memory and resources, right? So there must be a way for us to um, limit the resources that those containers are going to use. So that will be the topic for today, okay? Resource management. So, and this is important because we should strive for high compute density. It's not that we're going to use Kubernetes for running 10 containers or 5 containers, right? It doesn't make sense to run just a small amount of containers. We want to take advantage of those Kubernetes clusters like all the time, right? So this will increase the cost benefit of money spent on infrastructure because, as you might know, having a Kubernetes cluster is not going to be cheap, right? Of course, there are some Kubernetes managed Kubernetes options in the cloud, such as AKS or whatnot. However, it's not that you're going to spend too little money to not take advantage of that, right? So, resource boundaries, we can set those at the container level. That's the first demo that I want to show you today. That is, inside the container specification, we can set the limits that the container should use. Okay, so this can be specified on the specification. I mean, in the YAML file, the manifest file. We are going to create one of those files, and there you can set the resource limits. In other words, you can set the minimum amount of resources that that particular container should use. And on the other hand, we can set the container limits. So in one hand, we have the resource limits. I'm sorry, the resource requests. And on the other hand, we have the resource limits. Resource request is the minimum amount of resources, and resource limits is the maximum amount, okay? And on the other hand, we have resource quotas that are objects that we can create and apply to the Kubernetes cluster to limit the amount of resources that can be consumed by a set of pods in a single namespace. Because remember, this namespace is like a logical group of objects inside the cluster. So we can set those limits at the namespace level, right? So it makes sense if you think about it, because you can use namespaces for, I don't know, maybe you're using this namespace for this application and this other namespace for this other application, right? Or maybe you're using a namespace for one of your clients and other namespace for other clients. So you want to set those limits and those boundaries at the namespace level, okay? When I'm talking about resource types, I'm talking about CPU most of the time, right? This is going to be CPU or memory or storage, okay? In this session, I'm going to focus on CPU and memory. But of course, you can set some boundaries around storage as well. We're not going to see that in this particular session. And there are other less common resource types, such as network bandwidth and GPU resources as well, okay? However, I'm going to focus on CPU and memory. As I was mentioning before, we can use the manifest file, specifically inside the containers element, to set the minimum and the maximum resource boundaries, the resources that your containers are going to use. So let's first talk about resource requests. This is the minimum amount, okay? We can use the containers element, and inside the containers element, we can use the resources element, and particularly the requests element, to specify that amount of resources that you want to use, okay? Those values are going to be used by the scheduler when that particular component, remember the scheduler, that's one of the control plane elements in a Kubernetes cluster. The scheduler is going to use that information to decide which node to place the pod on, okay? So that's important because you can have, I don't know, a number of nodes in a cluster, and some nodes are going to be heavily used and some others won't, right? So the scheduler is so intelligent and smart, and it's going to decide, I want to deploy this particular application, I want to deploy this particular pod in this node, right? Node A or node B or node C, okay? So how in the world we're going to use that? So remember, this is at the manifest level. Of course, I'm showing you this pod, the specification. However, we can use this in a deployment as well, right? Because the deployment object has a pod specification inside it. So inside the containers element, as I was mentioning before, we have the resources element, and inside the resources element, we have the requests element, okay? That's the field that we're going to use, and inside that field, we can set memory, CPU, and whatnot. In this case, this example that I'm showing you right now, it's using 500 millicores, which in other words is half of a CPU, okay? So actually that's a lot of compute resources for this particular container, but of course, this is just only a demo, right? So please be aware of those measurement units. In this case, I'm using the M, which represents the millicores, and it depends on what resource we're talking about, right? So if we're talking about CPU, we're going to use millicores. And if we're talking about RAM, I mean memory, right? So those other units are different. So you better take care about that and see the documentation first before you do that, okay? So, okay, so this is great. This is for specifying your minimum amount of resources. And what about limits? This is the maximum amount of resources that a container can consume. Very similar to the requests, this is other field inside the resources element, inside the containers of the pod, okay? So in this other case, we also have containers and then resources as well, and then limits, right? So we use the resources.limits field, and you can use CPU and memory and whatnot. In this other example, as we can see here on the screen, I'm using 1000 millicores, which in other words is one CPU. So I'm telling Kubernetes, hey, you know what? This particular container can use the entire CPU, which is a lot, right? But again, this is just a small example of setting your resource boundaries, okay? 1000 millicores is one CPU, okay? So let's do that, okay? Let's go to this terminal. So I'm not using my regular machine. I'm in my laptop because I'm abroad. Anyways, I'm going to create a new deployment or a new pod, and I'm going to set some limits, okay? So let's open up Visual Studio Code. Actually, I did that beforehand. So you can see this to expedite this process, okay? So you know what? Let me copy this because I don't want to show you the stress right now. Let me do another my pod file. So my pod dash first, okay? Anyways, forget about this right now. Nginx, and we're going to use this. And then I'm going to show you the stress container image. So in this particular case, as you can see here on the screen, I'm setting those limits for this particular container. I'm telling Kubernetes, hey, you know, this particular container can only use a quarter of a CPU, right? 25% of the CPU, this is allowed to use. And in terms of memory, as you can see here on the screen, I'm setting 64 megabytes of limits, right? So the MI, that's the unit for megabytes. That's why I told you, you have to take a look at the documentation because it's not a regular MB. This is MI, okay? So other than that, this is just the regular manifest file for a pod. Let's open up the terminal and let's verify that I don't have any pods, which I do. Hold on, because I was doing some other things in here. Kubectl, delete, deploy, man, my app. Okay, forget about this. Get pods. Those pods are being terminated right now, which is actually what I want to do. Let's wait for some. Let's wait a little bit. Come on. Anyways, I want to show you this deployment that I'm going to deploy again, which is using the stress container image, because I want to show you what happens when you have those limits, right? Anyways, my first demo is just using this pod element. Okay, so it was deleted. This is great. Now I'm ready to apply this file, which is my pod dash first, right? And then kubectl get pods, and you know the drill. This is creating the pod, is trying to download the image if it's not already present, and it's running, right? So let me tell you one thing about this. I'm using Minikube as usual, right? Minikube status, because this is just a small laptop, okay? And I don't know what's, you don't have the required permission to complete this task. Anyways, I don't want to use Minikube status. I want to show you other commands. Anyways, my point here is that I'm using Minikube and I'm using the Hyper-V driver. And when you install Minikube, you don't have a lot of different add-ons in your Kubernetes installation, okay, in your Kubernetes deployment. So for instance, I'm telling you this because I want to show you this command, kubectl top, which is a command just like the regular htop or top command in the Linux world that allows you to see how many resources processes are using, right? So in this case, I can show you top and then pod to see that this particular pod is using how much memory, how much CPU cores, right? So the thing here is that the top command requires the metric server enabled in your Minikube installation. So you can actually do that by executing Minikube and then add-ons, and you can see all the different add-ons that you can install and enable in your own Minikube installation. And actually, the one that is required is metric server, okay? As you can see, I already enabled the metric server for this particular Minikube installation, okay? So you must do that if you want to execute kubectl top, okay? So you should execute Minikube add-ons, and then I think that's enabled, and then the name of the add-on, which is metric server. I could be wrong in this syntax. You can search for the online help about Minikube. But the gist of this particular topic is that you must enable metric server in order to execute kubectl top, okay? You should do that. Anyways, kubectl top, this is great. I want to show you this. And actually, that Nginx container, it has a very small footprint of memory and CPU. It's not very exciting to be running Nginx in a single pod, okay? And actually, you can execute top node to see the node resources, how are they being used, okay? Anyways, this is great. Let me kubectl delete pod my app, okay? So I want to delete this particular isolated pod. So get pods, no pods at all. And then I want to show you this other manifest file, which is a deployment. Okay, remember deployments? We actually don't deploy isolated pods. That's for sure. Most of the time, we want to deploy pods by means of a deployment, right? So this is our deployment. A regular deployment is using this match labels element to specify that the labels of the pods should be my app. They must be app, and the value should be my app. Okay. And here in the spec, I'm specifying another container image. This particular stress container image allows me to execute some stressful commands, right? For, increasing memory utilization or CPU utilization, right? So I'm executing this command, and it's stressing and stressing and stressing this application all the time in terms of memory, in this case. And as you can see here, I'm specifying some limits, okay? Let me show you first what happens if I'm setting up this limit, which is 25% of a CPU with 64 megabytes of memory, and I'm specifying 5 replicas, okay? Let me show you this, friends. Kubectl apply, and then -f my deployment.yaml, and this is going to be creating right now those pods, right? Running, and pending. What's going on here? 4 pods are running and 1 is pending. Why in the world is that? So the thing is that if I execute top and then pod, you can see that those 4 pods, those are using 25% of the CPU. There are no other resources left for me to deploy the 5th pod. Make sense? And this is because the limits that I set up in that particular manifest file, right? So in other words, Kubernetes is not allowed and it's not able to deploy the 5th pod because the first 4, those 4 are using the 100% of the CPU, right? So that's the reason why the 5th pod is not running. So kubectl get deployments, okay? Kubectl delete deployments, my app, and let's wait for this to delete those pods. Let me go back here. and those pods are being terminated. Anyways, I don't want to wait for that. And I just want to change the CPU limits for those containers. So each container is able to use the maximum amount of CPU is going to be 20%, right? So I'm allowed to run 5 containers of the same kind because of those limits. So I changed this. Let's go back here to the terminal. And now I'm ready to deploy again that deployment. Okay. Let's get all the pods again. Those pods are being created right now. 3 are running. And now the 5 of them are running, right? And if I execute a pod, let's wait for the metrics to be fetched by the top command, because as you can see, the metrics are not available yet. So you have to wait for a little bit, I don't know, maybe half a minute or 1 minute or something. Let's try again. And eventually I'm going to get those metrics, and we're going to see that each container, each pod is using 20% of the CPU, right? So yeah, eventually this is gonna receive those metrics. However, metrics are not available yet, which is nice. We're just going to see those pods running. Anyways, I'm going to return to this in a couple of minutes, okay? So that's great. This is for the container level, friends, okay? Most of the time, this is a real world situation where you want to limit those containers that potentially are going to be running on your Kubernetes cluster, right? On the other hand, we have those resource quotas objects that we can create. As I mentioned before, resource quotas, they allow me to specify the maximum amount of resources per namespace. Of course, I only have the default namespace right now. Maybe I'm going to create a new namespace and then a resource quota for that particular namespace. However, remember that those objects, they allow you to specify the maximum amount of resources per namespace, okay? And you can also use resource quotas to limit the quantity of objects that you can create. This is awesome because you can specify, hey, in this particular namespace, I want to limit for, I don't know, maybe 100 pods, or maybe 5 services, 3 deployments, and whatnot. Okay, those kind of objects. Remember the primitive objects that we talked about, like, I don't know, maybe 1 month ago. And actually, you can limit a lot of different objects, not only the primitive objects that we talked about here in this series, but other objects as well. Okay. So let's go back here to the terminal. Let's clear up the screen. Kubectl top pod, and now I'm receiving those metrics from the pods. And as you can see, those pods are using 20%, not 25, 20% of CPU, each one, right? So this is nice. Limits are great. And the stress container image is allowing me to stress those applications, those pods, so we can see that in the kubectl top command. Awesome. So returning to the resource quota objects, as you can see here on the screen, this is another kind of object that we can create. So in this case, this is the manifest file for our resource quota. As you can see here, this is the resource quota object. Okay, the API version is v1, the kind is resource quota, and of course we can set that metadata because most of the time we need the name, In this case, is my resource quota, my RQ, right? And then we have the spec field that has hard, and then the different resources and objects that you want to limit. You're specifying the quota in this particular field, okay? So for instance, CPU and memory, those two are for computing resources, right? 2 CPU cores and maybe, I don't know, 4 gigabytes of RAM. That's the quota for this particular namespace. Of course, you're not specifying the namespace here. However, when you apply the resource quota object, you have to specify the namespace. I'm going to show you that. Okay. And pods 10. This is an object count quota, which is, again, this is awesome. We have a lot of flexibility in terms of this quota specification. So this is great. And then you need to deploy that particular manifest. Again, kubectl apply, just a regular kubectl apply file, my quota.yaml, or the name of the file, right? And that particular command is going to deploy the resource quota in the current namespace. If you want to deploy that quota in another namespace, you have to use the flag -n or double dash namespace and the name of the namespace where you want to deploy this particular resource quota, okay? And again, kubectl get quota, this is for returning and displaying all the different quotas. As you can see here, the alias is quota, right? It's not, you can use actually, I think, resource quota, the entire name as well. However, quota is just an alias. And the final one, it gets all the detailed information about a particular resource quota, okay? It's just a regular kubectl describe, right? Actually, you know what? This is a typo because it should be lowercase. This is great. Thank you. Okay, so cool. Let's do this, okay? Let me copy this because I don't have a template for creating quotas and I don't want to type everything, right? My resource quota, YAML, let's type this, kind resource quota, my resource quota, 2 CPUs and 4 gigs of memory and 10 pods and whatnot. Very easy thing to grasp. And here, kubectl apply, right? And then my resource quota, and then the namespace. Of course, I need to create another namespace. Kubectl create namespace, and I don't know, maybe test. And now we have that test namespace, right? And now I'm able to kubectl apply -f, my resource quota.yaml, and the namespace is test, right? So now that particular quota was deployed in the test namespace. So I can actually describe quota, my resource quota, which is in the namespace test, and we can see that that hard limit at the right of the screen, I mean, the last column is the hard limits that I set in the manifest file. And in the middle, we can see the used number of objects or the limits of those compute resources, right? In this case, because of the fact that I don't have any kind of object inside that namespace, of course, those values are 0. However, I think I can use my deployment again, right? My deployment.yaml, my deployment.yaml namespace test. Okay, and now kubectl scribe, blah, blah, blah. And we can see that at this moment, I'm using one of those CPUs, and I'm using half of the pods that I specified in the quota, right? And I'm only using 320 megabytes of those 4 gigabytes. Anyways, you can easily see that with this kind of resource objects, resource quota objects, you can set those limits at the namespace level, which is great. Okay. So I believe this is all I have for today. Okay. Just as an overview, you can set those limits at the container level by using limits inside the pod specification. You can also set those resource requests for specifying the minimum amount of resources that your applications need. And that's for the container level, right? And on the other hand, you have those resource quota objects that you can create, and you can apply those at the namespace level. Okay? So this is great. And I only have one screen right now, friends, because I'm abroad and I don't have my entire my 3 monitors, right? So this is all I have for today. So I'm not watching the comments and questions. However, in the next session, session number 11, we're going to see the multi-container pods, right? I'm going to talk about how you can create pods with multiple containers, because most of the time, if you need that, it's because one of those containers need the other one for its own logic and functionality. So we're going to see how in the world we can create that in Kubernetes, okay? So that's everything for today. I thank you very much for your time, and I'll see you next time.